Today we're going to learn about scientific notation. This is a great practical example of how you're going to use exponents in your life. But what is scientific notation? Scientific notation is a method of writing or displaying numbers in terms of a decimal number between 1 and 10 multiplied by a power of 10. So the example in front of you shows a very large number, and what you've done is they've taken the decimal point and they've moved it 7 places to the right until we've made a number that's in between 1 and 10. That number is 6.5. Then they write it as times 10 to a power. The power here is how many places the decimal point was moved to make that number into a number between 1 and 10. So that is an example of scientific notation. Scientific notation is not just seen in the math classroom. It's actually used in multiple real-life occupations and situations. Astronomers, chemists, engineers all use scientific notation on a daily basis. Engineers use scientific notation when they're working in construction. One example of engineers using scientific notation is when recording the pressure on a supporting beam of a bridge. Astronomers use scientific notation when working with large distances in space, like if you wanted to find the distance from here to Mars. An example of this would be when they measure how far one galaxy is from another. Chemists use scientific notation when measuring and working with very small objects. If you would jump into a chemistry class and listen to the conversation, you would definitely hear a lot of scientific notation occurring. Another example of a chemist using scientific notation is when measuring how small a molecule or an atom is. Scientific notation is written differently when working with small or large numbers. If the number is below 1, like less than 1, the exponent will be negative, as you can see right in these two examples here and here. My number was less than 1 to begin with, so when I write it in scientific notation, the exponent becomes negative. If the number is greater than 1, or 1 or greater, then the exponents are positive, as you can see from the other examples. Scientific notation is valuable in our world because many jobs will use or require it. Many occupations, such as a chemist, astronomer, and engineer, use it on a daily basis when writing down numbers that are too big or too small to be written out in a reasonable amount of time. Now I'd like you to take out your packet and turn to page 15, and we're going to start practicing writing numbers in two different forms. The first form we're going to look at is writing a number in standard form if you're given a number that's in scientific notation. And then we're going to do the opposite. We're going to look at a number that is in standard form and see if we can turn around and write it in scientific notation so that you can learn how to go back and forth. So we're going to start with page 15, bottom left. Go ahead and take a second and copy down these 3 problems, and then we're going to go through them. How do we change them into standard form? You can hit pause and hit play when you're ready. Okay, well the very first problem that we see is 4.11 times 10 cubed. What we're going to do is we're going to change it into the original number that it was. So because my exponent here is positive, right there, that tells me that I have to move my decimal point 3 places to the right to get the original number. So I move it once, twice, and now I have to add another 0 on there to move it a 3rd time. And so my final answer for that would be 4,110. So those two numbers are equal. Remember, scientific notation starts with the number between 1 and 10, and then it's times 10 to a power. Okay, again, this has to be a number between 1 and 10. Let's look at our next example of going the opposite direction. So we have 7.61 times 10 to the 11th. So what I have to do is take my decimal point and move it 11 places to the right. Now that's going to be quite a few zeros. If I move it 2 places to the right, Sorry, I'm having a little bit of trouble here with my pen. It keeps going back and forth. If I move it 2 places to the right, I'll be behind the 1. So now I've got to add another 9 zeros. The final answer would be, I don't even know how you'd say that. Let's see, 760 billion. Now let's look at the next one. 7.45 times 10 to the 8th. Go ahead and try that on your paper. Hit pause and hit play when you are ready. All right, so if we want to take this number here and put it into standard form, you would start by moving the decimal point 2 places to the right, and that would get you behind the 5. But we have to move it 8 places, so we have to add in 6 more zeros, and the final answer that you should have gotten would be 745 million. So hopefully you did okay on those. That was taking scientific notation and putting it in standard form. Standard form is the form that you are used to of numbers. All right, so I'm going to clear this screen, and then we're going to go to the next page. Now we're going to go the opposite direction. So we're still on page 15, bottom right. We're going to take a number that's very large, and we're going to write it in scientific notation. So again, step number 1 is we want to take that number, and we want to put a decimal point in it to where we make it into a number between 1 and 10. So the place where that's going to have to happen is right there. Then I would have 7.3. Now we have to see how many places we moved the decimal point to get to that spot. So this would be 3, and then another 2, so that would be 5 spaces. So my answer would be 7.3 times 10 to the 5th power. Now you try the next 2, hit pause, and hit play when you are ready. All right, well, let's see how you did. The first, or the second one, part B, you should have had 6.1 times 10 cubed. And then in the very last one, you should have had 8.915 times 10 to the 9th power, because you had to move the decimal point 9 places, 3, 6, 9, to get to that number in between 1 and 10, 8.915. All right, so that's how you do standard form of scientific notation for larger numbers. Now we're going to look at some smaller numbers. Please have your notes opened up to page 16. So as stated earlier, whenever we have numbers that are very small, in scientific notation, they have a negative exponent. So my first example, and you can copy it down on letter A, 8.04 times 10 to the negative 5. So when I want to write that in standard form, because I have this negative exponent right here, that tells me this number was small, and I've got to move my decimal point to the left 5 places to make it into that original number in standard form. So if I move it 1 place to the left, I'm in front of the 8. I'm going to have to add 4 more zeros in front of that to make it the number in standard form. And so the answer would be 0.0000804. Now, you copy down letter B and C and try changing them into standard form. Hit pause and then hit play when you are ready. All right, so letter B, you had to add in a lot of zeros. If you move the decimal point 1 place, just 1 place to the left, you're in front of the 5, but you have to go another 12 because we need a total of 13 places to the left. And then in letter C, you had to move the decimal point 2 places to the left to make it into the number in standard form. Let's reveal the answers and see how you did. This is what you should have had for both of those answers. And hopefully you did okay. Now on the bottom right of that same page, we're going to go the opposite direction. I'm going to give you the really small number and then ask you to change it to a number in scientific notation. So remember, the first thing you always want to do when you write a number in scientific notation is make it into a number between 1 and 10. I would have to move my decimal point 1, 2, 3, 4, 5 places to make that into 7.48, which is a number between 1 and 10. Because the number originally was a very small number that was less than 1, excuse me, all kinds of things are happening here. Had a little trouble with my Active Inspire. This is what the answer would be, 7.48 times 10 to the negative 5. Again, the exponent is negative because my number to begin with over here was less than 1. And we had to move the decimal point 5 places to get to that 7.48. Now you copy down the next 2 and then see if you can change them into scientific notation. Hit pause and then hit play when you are ready. All right, well, let's reveal the answers and see how you did. The letter B should be 9.3 times 10 to the negative 4th, and letter C should be 5.6 times 10 to the negative 8. All right, turn to page 17 in your notes, and I'd like you to do the practice problems. There are 8 of them at the top of the page, changing numbers of scientific notation and changing them back into standard form. Get a little bit more practice in to see how good you are at this, and if there's something that you need to improve upon or ask me for help. Remember, a number in scientific notation starts off with a number that's between 1 and 10, and then it's times 10 to a power. The power is positive if the number is greater than 1 to begin with, and the power will be negative if your number was very small to begin with. All right, go ahead and hit pause and hit play when you are ready. So, if you will, please check your answers with mine and see how you did. Just hit pause on the video, hit play when you're ready, circle any that you missed, and be sure to ask your neighbor or me for help on the ones that you missed if you don't understand. If you understand what you did wrong, then that's awesome. I have one last important idea that I need to cover with you. It's another great example of applying some of the things that we've been learning. We've been learning how to multiply numbers together that have exponents. And so because scientific notation is so commonly used in the world, we're going to learn, well, how do we multiply numbers that are in that form? And again, we're going to just use the same rules that we learned with our exponents. So I'm on page 17 in the middle. If you would, just look at the practice together part. And the first problem says 1.5 times 10 to the negative 4th times 5 times 10 cubed. And I know we've said several times this year that when numbers are being multiplied together, we can change the order. It's called the commutative property. So this particular problem here, I could actually do the 1.5 times the 5 and just change the order up so I have my plain numbers next to each other. And then I could multiply the 10 to the negative 4th times the 10 cubed. So all I've done is change the order, which we're allowed to do because all 4 of those things are multiplied together. So notice what I'm basically doing. I'm multiplying the 2 regular numbers together, and then what I'm going to do is multiply the tens that have an exponent on them. So when you do that and you multiply the 1.5 times 5, you will get 7.5, and when you multiply the 10 to the 4th times 10 cubed, you'll get 10 to the negative 1, because when we multiply, we add the exponents. And a negative 4, right here, plus 3 gives you a negative 1. So now that I showed you that, I'd like for you to try the next example and see what you can do with it. Hit play when you are ready. All right, well, let's see if you did this correctly. So to get started, you multiply 4.5 times 6.3, and you get that answer. Then you multiply 10 cubed times 10 to the 7th, and again, remember our rule: when we multiply, when the bases are the same, we add the exponents. So I'm going to add the 3 and the 7. There's a tiny trick to this problem, because some of you, or most of you, probably got this. But there's a little bit of a problem with that. This is not in scientific notation. So I want you to think a minute as to, like, what could be wrong? Why is this actually not in scientific notation? The reason is this number right here. Remember that a number in scientific notation has to have as its first number a number between 1 and 10. This is not. So this is actually 2.835. And then if I would have to multiply by another power of 10 to get it over one more space, then it would be about times 10 to the 11th power. So that is how you multiply numbers together in scientific notation. Okay, so finally, if you would please, on page 17, do the problems on the right, the you try problems, and you practice multiplying the 2 numbers together that are in scientific notation. Remember to multiply the regular numbers together, and then multiply the numbers that have the base of 10 with their exponents. Do that on both problems, and I'll reveal the answers in a second. All right, well, hopefully you got these right. Let's see. The first one, you should have 6 times 10 cubed, and the last one, the final answer is actually 1.65 times 10 to the 10th. That's it for scientific notation for now.